Howdy, AP Pre-Cal. It is Miss Kosh. We are looking at some unfriendly, unit circle unfriendly inverse trig stuff. And so I wrote out a whole bunch of these different angles, and I want to find where they are, where they fall on the unit circle. So one way to think about that is off to the side, you could write which quadrant they're in, off to the side over here. Or you can label the angle over here. So for example, this first one, arc sine of 4/5 would be there in quadrant 1. And then since arc sine lives in quadrants 1 and 4, this would be arc sine of negative 4/5 down here. Well, then I also asked the question, box any angle that is not in the domain of 0 to 2 pi. Well, this angle right here, arc sine of negative 4/5 would actually be a negative angle right here. It would be smaller than 0. And so that would be one that we want to box. Oh, I forgot to. This is quadrant 1. This lives in quadrant 4, but it's less than 0. Okay, so then what happens if I'm at arc sine of 4/5 and I add pi? Well, arc sine of 4/5 we just put in quadrant 1. When I add pi, I am now arc sine of 4/5. Maybe we could put the parentheses. We don't really have to, but it does make things easier, a little clearer. And plus pi, so that puts us there in quadrant 3. Okay, what happens when I take arc sine of negative 4/5 and I add pi? Well, I start in quadrant 4, the negative way, and then I add pi, so that puts me in quadrant 2. This is arc sine of negative 4/5 plus pi. And so we are now in quadrant 2. I was smaller than 0 when I was in quadrant 4, and then when I add pi, I'm now between 0 and pi. So I don't need to box that one. Okay, a negative arc sine of 4/5. Well, if arc sine of 4/5 is here, is this angle, then the negative is going to come down this way. I'm going to get too cluttered, so I'm going to erase those. But this one right here was a negative arc sine of positive 4/5. This is in quadrant 4, but this one is actually negative. Okay, so it took this positive angle here, turned around and made it negative, and so that's going to be smaller than 0. So it's not inside that domain. Okay, the next one, I have a negative arc sine of negative 4/5. Well, arc sine of negative 4/5 gets me down there, but when I make it negative, now I'm coming up here. So this was a negative negative. This is now a positive. So we have a negative. We could call this angle. Now, it would be kind of annoying to call it that, but we could call this negative arc sine of negative 4/5. And then this is now in quadrant 1, and it is within 0 and 2 pi. The next one, negative arc sine of 4/5. So arc sine of 4/5 is here. Negative takes me down there. I add pi to this, and now I'm over here in the third quadrant. So this is negative arc sine of 4/5 plus pi. Let's get rid of these arrows because they add a lot of clutter. And so this one is in quadrant 2. The next one, I have arc sine of negative 4/5 would be here. Make that negative, we're here. Add pi, we're here. Okay, so this is negative arc sine of negative 4/5 plus pi, and that would be in quadrant 3, and we would be fine. We would still be between 0 and 2 pi. Okay, the next one, pi minus arc sine of 4/5. Okay, so arc sine of 4/5 is that angle right here. So if I'm at pi, and then I subtract away this amount, I've come back to here, and I'm now in quadrant 2. So this is pi minus arc sine of 4/5. All three of these are legitimate ways to name that angle. And I have seen AP, on AP Classroom, they asked, you had to solve an equation, and it left you some weird stuff, and you had to answer between 0 and 2 pi, and it was just a little confusing. So I'm trying to help us learn how to think through where do these angles fall. This would probably show up, this will definitely show up if it's on the AP exam in the multiple choice. Yeah, I feel pretty comfortable saying that. Okay, let's look at the next one. 2 pi would be, we've gone all the way around here. Here's 2 pi. And now we back up. Well, this is arc sine of 4/5, that amount, so we're going to subtract and go that way. And so we end up at this angle. This is 2 pi minus arc sine of 4/5 which makes sense because notice negative arc sine of 4/5, and then this 2 pi just makes something coterminal to what came. Do you see how these two are almost the same? They're not the same, but they're coterminal to each other because of the 2 pi. So hopefully that makes sense to you. Let's see. Let me erase some of this clutter. I forget that it doesn't stay on the eraser. And different things I erase different ways. Okay, I didn't write it down, but that was quadrant 4. Okay, so, and that would be between 0 and 2 pi. Then I want to do the same sort of thing, but with arc cosine. So arc cosine lives in quadrants 1 and 2. So this first one, this will just be arc cosine of 3/5 right here. So this is quadrant 1. Arc cosine of negative 3/5 puts me in quadrant 2. And it's between 0 and 2 pi, so we're fine. This is quadrant 2. Arc cosine of 3/5 plus pi means that I'm going to be over here. I started in quadrant 1, and then I added pi. Here's this plus pi. I'm now in quadrant 3. Okay, arc cosine of negative 3/5, that was in quadrant 2. When I add pi, I'm now in quadrant 4. Arc cosine of negative 3/5, and then I add pi. This is quadrant 4. A negative arc cosine of 3/5. If this is arc cosine of 3/5, then a negative is going to put me down here. But this will no longer be in our domain. That's now going to be smaller than 0. And so we are negative arc. But it might be helpful to use that angle, or you might see that somewhere. But it's definitely smaller than 0. Okay, a negative. Okay, if this angle right here, so here's our initial side, here's our terminal side, we end up like this. If we make that angle negative, now we're doing this. And so this becomes this, it's now in quadrant 3. Oh, I forgot to write down that this was in quadrant 4. But this one is also going to be too small. It's going to be smaller than 0. It's a negative arc cosine of a negative 3/5. And so that is a negative angle, but they're in quadrant 3. Let's get rid of the clutter. Okay, now we're looking at negative arc cosine of 3/5, which I actually wrote down here. And so that was a negative measure, and then so when I add pi, I'm now going to go over to here, and this is negative arc cosine of 3/5. So arc cosine of 3/5 was in quadrant 1. Making it negative, I end up in quadrant 4. And then, where am I? Oh, plus pi puts me in quadrant 2. Okay, the next one. Negative arc cosine of negative 3/5. Okay, arc cosine of negative 3/5 is in quadrant 2. So that's here. Then I make it negative. I'm now in quadrant 3. I add pi. So it's a negative value, but when I add pi, I'm positive again. And so this one is a negative arc cosine. Oh, I just forgot. What did I see? Of negative 3/5 plus pi. I did not save myself enough space. There you go. Let's clear the clutter. That we just said was quadrant 1. Pi, so pi would be here, minus arc cosine of 3/5. Arc cosine of 3/5 is an angle that big. When I subtract this away, now I'm at that angle right here. Okay, so this one, pi minus arc cosine of 3/5. I tried to come up with as many ways to label these angles. I came up with a lot. Are there more? Maybe. If you come up with some more, let me know. And then 2 pi would be all the way around here. And then arc cosine of 3/5 is this angle. So if I subtract that, now I'm here. And so let's get rid of that clutter. Oop. This was a quadrant 2, right? Okay, that's a 2. I am here, 2 pi minus arc cosine 3/5, and that's still bigger than 0, less than 2 pi, and that's in quadrant 4. I hope that's helpful. Okay, a little bit more. I just basically used those and wrote equations, but the directions are what matters here. It says solve for the exact value. That means we're not going to have decimals on this interval for the following equations. So I come along and say, oh, super sine is equal to 4/5. Sine is my y value on the unit circle. So that's here and here. This first one is theta would equal arc sine of 4/5. But this one is not isn't easily expressed using arc sine. So what we can do is we can then say, well, it would be pi more than arc sine of negative 4/5, because negative 4/5 would put me here, coming this way. And then I'd add pi, and then it would put me in the right thing. And this would be in the right domain. Is there another way to say this? Probably. Let me think about that for a second. This would be, it would be pi. You could also say pi minus arc sine of 4/5. I actually did this earlier. Oh, no, I had to come here. And this is my unit circle unfriendly. This is the key that I made. I said pi, okay, I have those two, and then I went to Desmos and plugged them in. So here is that first one, and if you notice, these are our radian measures, and when we look at the unit circle, pi is about 3.14, and so these seem like a reasonable answer inside that world. The next one, you know what, I'm just going to keep talking through the problems I already did. The next one then said 5 sine theta plus 4, so I subtract and divide, and I want the y value where those are negative, and so one of them, this one right here, if I do arc sine of negative 4/5, then what that means is I got here in the negative direction. Well, I don't want to go in, and if I do, then my value is too small, and it doesn't live inside this domain. And so I have to add 2 pi to end up with the correct answer. Or, what else could I do? I could, or I could say that it was 2 pi minus this positive angle. So this arc sine of 4/5 would be in quadrant 1. I could subtract that away. And then to get the quadrant 3 angle, what I wrote down was arc sine of 4/5, which would have been here-ish. And then I add pi, and I end up right there. Okay, so, and then I double-checked by going to Desmos. And they seem to make sense as to, like, not getting close to 6.28, because 2 pi would be getting close to 6.28, but they're not quite there yet. But the nice thing is that these two that I wrote gave us the same decimal approximation, and then the other one seems to fall into quadrant 3. It does. Okay. And then I said, well, what happens? Same idea, same exact situation, but now let's look at cosine. So cosine will be positive in quadrants 1 and 4. Cosine will be negative in quadrants 2 and 3. But arc cosine only gives us an answer in quadrant 1 and quadrant 2. Okay, so I found this one, arc cosine of 3/5. That gives me this particular answer. And so then you have different ways to generate this one. So either we could come out to 2 pi, so go all the way, and then back it up this much, arc cosine of 3/5. Or you could say it's the negative, which puts me here, and then I add pi. So I went here, this is arc cosine of negative 3/5, and then I add pi, and now I'm in the correct spot. I hope this is making sense. And yeah, and then my decimals, I wonder if did I crop that too much? Apparently I did. Well, that's not helpful. Okay, I'm good, but not perfect. Okay, so cosine of negative 3/5 puts me in quadrants 2 and 3, like we said. Arc cosine of negative 3/5 is fine. That is this one. And then we have to, if we want to end up in the third quadrant, we could start in the first quadrant here and then add pi. Or we could say 2 pi minus, well, this arc, hang on, let me get rid of some of that clutter. This angle right here is arc cosine of negative 3/5. If I take 2 pi, what I have done is I have gone all the way around here, and then I'm subtracting away that amount. And so then it sends me back to where I want to be. And I think I did show the decimal approximations. All right, like, subscribe, comment, and go practice. Hopefully this was helpful. Let me know what else I can do for you. Good luck.